In our lesson video today for day 3B.2, we are going to be identifying properties of quadrilaterals and specifically parallelograms and rectangles. So as we study in this unit quadrilaterals specifically, remember quadrilaterals, there are four sides. There are some subcategories or special quadrilaterals we're going to be looking at. The first two are parallelograms and rectangles, and that's what this lesson is going to cover today. So as we jump into taking notes here, we first want to look at what a parallelogram is. And there are these 5 characteristics we're going to look at that make something a parallelogram, and all parallelograms have these properties or characteristics. And so as we look at these, the very first one we want to understand is actually our definition of a parallelogram. A parallelogram is a quadrilateral in which opposite sides are parallel. Okay, so if these opposite sides are parallel, we have parallel sides here and here, but we also have parallel sides above and below. AB would be parallel to DC, AD is parallel to BC. But we have other characteristics that help us understand what parallelograms are. So not only are parallelograms, not only do parallelograms have opposite sides that are parallel, but opposite sides are also congruent. Okay, so these opposite sides would be congruent in length, same length. Okay, and we have some more characteristics we're going to be looking at. All right, we understand about sides, that their opposite sides are parallel and congruent, but we also have some relationships with angles we're going to be looking at. Okay, now opposite angles, you'll notice, are actually congruent as well. All right, opposite angles are congruent. Like angle A would be congruent to angle C, and angle D would be congruent to angle B. Right? Because we have this relationship with these sides that works out that way. Opposite angles are congruent. But we also need to understand something about the angles that are not opposite, angles that are considered consecutive angles. And you remember that term from the previous lesson. Consecutive angles are next to each other, or they share a side. Consecutive angles like A and D are actually supplementary. They add up to equal 180 degrees. And you'll remember that from our discussion about parallel lines. Okay, if I look at these as parallel lines, I have parallel lines here, cut by this transversal, which makes angles A and D consecutive interior angles, which you might remember are supplementary. And so consecutive angles of a parallelogram, because those opposite sides are parallel, are supplementary, meaning they add up to 180 degrees. Okay, so angle A plus angle D equals 180 degrees. Now there's one other characteristic we want to look at, and that is the characteristic of something called the diagonal. A diagonal connects two opposite corners of a polygon, or two opposite corners, opposite vertices of a parallelogram in this case. So we have a diagonal that runs this way and a diagonal that runs this way, and those diagonals intersect each other in such a way that the intersection of the diagonals is actually the midpoint of both diagonals. And here's how we say that. We say that the diagonals bisect each other. So if I had called that point X, just to label it with a point, DX would be congruent to XB. And AX would be congruent to CX or XC. So the diagonals bisect each other. Now, all 4 parts are not necessarily congruent because you'll notice one diagonal is longer than the other, but they do bisect each other into equal parts. So now we're going to go ahead and take a look at applying these characteristics to solve problems. So in this first example, we're going to be using several different properties of parallelograms to find these missing measures. And think of it like a puzzle, trying to find all the pieces that they request. Sometimes you just have to find all the pieces. And so as we look at this, all right, we would maybe look at UT first. UT is that side. Well, that's a side of a parallelogram. So let's think, what do we know about sides of parallelograms? So I'm going to go back to my list, and I know that opposite sides are parallel and opposite sides are congruent, which means that UT is the same length as its opposite side, RS, so UT is 27. Then it asks for ST. ST is the opposite side of RU, so those are both the same measure, so ST is 18. But now let's look at VS. VS is only part of a segment here, that the bigger segment would be US, which is a diagonal. Since that V is the intersection of the diagonals, remember, the diagonals bisect each other. Okay, that means they cut each other into equal halves. So if UV is 7, VS is also 7. So my answer for this blank is 7. Then they ask about VT. Now VT is this one. VT is half of the other diagonal, but it doesn't look like there's anything there, which is why we've added in this extra piece of information. The full length of RT is 30. Well, VT has to be half of that. So VT is 30 divided by 2, which is 15. Okay? So those are the kind of properties we can use. Sometimes we use angles as well, like in number 2. So some of these are side measurements or segment measurements, others are angle measures. So we need to, again, keep going back to that list of things that we know about parallelograms based on their properties about sides, angles, and diagonals. Number 2, first thing they ask for is AD. AD is the opposite side of BC, so that means they are both 8. Okay, DC is the opposite side of 15, or of AB, which is also 15. You can even write them in if you want like that. Sometimes adding the measurements to the picture is going to be helpful for you. But then they start asking about angles. The first angle they ask about is the measure of angle A. Well, I know A and C are congruent, but I don't know what C is. But you need to remember that yes, opposite angles are congruent, but consecutive angles are also supplementary. So since consecutive angles are supplementary, that means A and D, measure of angle A plus measure of angle D, must add up to 180 degrees. Well, the measure of angle D is 68. So the measure of angle A would just be 180 minus that 68. And 180 minus 68 is 112. So the measure of angle A is 112 degrees. Remember though, opposite angles are congruent. So that also tells me the measure of angle C is 112 degrees. I should put my degree symbol there. Then they ask about the measure of angle B, and it is the opposite angle of angle D, so they're congruent, so it's just 68 degrees. Okay? Let's keep going. Now, as we continue working through these examples, sometimes I ask for a lot of information, other times I ask for just one piece of information, and it might involve setting up an equation. So what I want us to do on these, anytime I give you a blank here where it says property used, I'm wanting you to use or write down the property of that shape that we are using, the property of parallelograms in this case that we're using. So you'll notice to find the measure of angle B, that's not given to us. So there's actually 2 different properties we could use. But what I really want us to focus on is the property we're going to use to set up our equation, okay? So we'll come back to finding the measure of angle B in a minute. But first, we need to recognize that angle A and angle C are opposite angles, which means they are congruent. So I'm using the property that opposite angles are congruent. And I can use the abbreviations and symbols to make that property easier to write. Okay, and if they are congruent, that means these are equal values. So my equation is 6x minus 15 has to equal 4x plus 11. All right. Now, to solve this, you guys should know how to do that. So I'm going to kind of speed through this and show you what the value of x is. We get x should equal 13. Now, they ask for the measure of angle B. You need to understand something. Measure of angle B is a consecutive angle with the measure of angle A. So what I'm going to do is plug in to find the measure of angle A first. 6 times 13 minus 15. Okay, when I do that, and then I subtract that from 180, we're going to get this. We get the measure of angle A is 63 degrees. So the measure of angle B is 180 minus 63 degrees, or 117 degrees. Okay, let's try another one. All right, here we're asked to find the measure of angle R. We're going to do this in a very similar setup, but this time we're using the properties about angles in a different order. Here we are given consecutive angles first, and you need to understand that consecutive angles are supplementary. Okay, so we can abbreviate. That means they add up to 180 degrees. So to find x, this is the equation we write. 8x minus 12 plus 3x plus 5 equals 180. And this equation will help me find x, but then to find the measure of angle R is opposite the measure of angle P, so they are equal. So all I have to do is plug into the measure of angle P. So here's what we're going to do now. We are going to combine our like terms. 8x plus 3x is 11, and negative 12 plus 5 is minus 7. Then we can add 7 to both sides. Then I can divide by 11. And when I divide both sides by 11, I get 17, and x is 17. So I'm going to take that 17 and plug in for the measure of angle P, because that's also equal to the measure of angle R. So I'm going to do 3 times 17 plus 5. And when I do 3 times 17 plus 5, I should get 56 degrees. And that's the answer for the measure of angle R and P, because opposite angles are congruent. And so you will get more problems like that when we are working with our properties of parallelograms. But the other quadrilateral we want to look at today is a rectangle. So we're going to turn the page, and we're going to look at properties of rectangles. Now, you need to understand this about rectangles. Rectangles have all the same properties of parallelograms, because a rectangle is a specific parallelogram. If I looked at all the properties from parallelograms, every one of these would still be true about rectangles. Okay, so what we're going to do first, for our first property, we're going to kind of combine all that into one. We're going to say that all properties of parallelograms, which, by the way, there's a symbol we can use for parallelogram, and that's this symbol. I'm just going to draw a parallelogram like we did a symbol for triangles. It's just a triangle. That's a parallelogram. So we can use that to replace the word parallelogram. But let me finish. All properties of parallelograms apply to rectangles. Okay? All the properties of parallelograms from the previous page are still going to apply to rectangles. Opposite sides are parallel and congruent. Opposite angles are congruent. Diagonals bisect each other. Consecutive angles are supplementary. All those still apply. Now, what you need to know about rectangles, though, our basic definition of what a rectangle is, though, is a parallelogram where there are 4 right angles. A quadrilateral with 4 right angles must be a rectangle. Okay, and I can mark that like this, that those are all right angles. And so as we look at that, that tells me that every measure there would be 90-degree angles. Okay, and as we continue talking about rectangles, there's another property we need to look at, and that concerns the diagonals. And so if I draw in the diagonals here, what we notice about that is the diagonals are actually congruent. So not only do they bisect each other, but all 4 pieces would be the same because they're also the same length. All right. Now there's another property. We actually aren't going to do all 5. We're just going to use a 4th line here. There's another property that is actually a property of right triangles, but it's going to be very applicable, meaning it's going to apply to these rectangles. I want you to understand something. I'm going to highlight just one of these right triangles we get. Okay, you'll notice that one diagonal splits a rectangle into a right triangle. Your property that we need to understand that in a right triangle, in any right triangle, we have two of these angles here that are considered the acute angles. Those acute angles, meaning the ones that are not the right angle, the acute angles are complementary. What does complementary mean? You might remember back to our first unit of study. Complementary angles mean they add up to 90 degrees. Because all three angles add up to 180 in a triangle, and we already have one right angle, which is 90, 180 minus that 90 is a remaining 90 degrees split between those two other angles. And so that's actually an important property of right triangles that is going to help us in problems with rectangles sometimes. All right, so let's continue and let's do an example using rectangle properties. But remember, all the properties of parallelograms still apply. So in this case, when they ask for the length of QR, QR is opposite the side PS, and that's a parallelogram property that opposite sides are congruent. Okay, so in QR, that's 10. Same thing for SR. SR is opposite PQ, so those are both 24. And now we start looking at the diagonals. Now these three pertain to the diagonals, but this is an important note at the bottom of this box. For SQ, PR, and QT, we're going to use the Pythagorean theorem because this does create a right triangle. Otherwise, there's not enough information there to do that. But I have two legs of a right triangle. I have an A leg and a B leg. And so this hypotenuse, SQ, I can call C. So I can find SQ first by doing this. A squared, or 10 squared, plus B squared, or 24 squared, equals C squared, or we'll just call that length SQ squared. So I'm going to solve for SQ. 10 squared is 100. 24 squared, when you use your calculator, you'll notice it gives you 576. And so I'm going to add those together now. 100 plus 576 is 676. And so to undo the SQ squared and find the length of SQ, we're going to take the square root of both sides there. So SQ is the square root of 676. And when you use your calculator, you will find the square root of 676 is 26. So this diagonal SQ is 26. Remember in a rectangle that the diagonals are both congruent. So PR is also 26. Now QT, you'll notice, is a length that is half of that full diagonal. I know it's half because in a rectangle, which is also a parallelogram, the diagonals bisect each other. So I know T is the midpoint of both diagonals. So I'm going to take 26 and divide it in 2. 26 divided by 2 is 13. And so as we continue to look at properties of rectangles, okay, there's some other information we're going to use. And so this time they're asking me all about angles. And so this is very much like a puzzle piece problem where we're going to find all the information. And in fact, we are going to, before I fill in any blanks, we're just going to find all the angle measures here because I've got a rectangle, but I also have these 4 triangles inside that. Within those triangles, I've got intersecting lines. I know that I've got vertical angles that are the same or congruent angles. I've got linear pairs that add up to 180. All the angles of a triangle add up to 180. I've got parallel opposite sides, which we get these zigzagging lines through there, creating alternate interior angles, which are also congruent. So there's a lot of information going on. There's a lot of ways I can go about and explain this, but it really breaks down into there's only a few different angle measures I could have. Okay, we know that the total angles at the corners, J, K, L, and M, those are the 4 right angles of a rectangle. Right angles are 90 degrees. So I'm going to start just at one place here by using this right angle, which is 90 degrees total. I'm going to subtract that 27 from that and get a 63 degree angle. Okay, and so that angle 63, that's actually going to help me out with 3 other angles. There's going to be 3 other angles that are 63, and here's why. Because this triangle is here, Shape kind of looks like an envelope. But because of that triangle, I know that it's formed by two parts of the diagonals. The diagonals of a parallelogram bisect each other, and the diagonals of a rectangle are congruent. So I know that JN has to be congruent to KN. And that makes that triangle an isosceles triangle. And in an isosceles triangle, these two angles are congruent. So that's 27. And because I have congruent triangles here on the top and bottom, these would both be 27s. Or I can think of it this way. I can think of alternate interior angles, 27 and 27, like that. Okay, but those are 27s. That makes these other angles 63 degrees. Okay, and this is an angle that's 63 degrees. So all the corners are going to match up because we've got some symmetry to this rectangle. That just leaves these angles in the middle of the intersecting diagonals. Well, let's remember, in any triangle, the three angles for a triangle add up to 180 degrees. So 27 plus 27 at the top here is 54. Okay, and 54, if I subtract that from 180, I get 126 degrees. That means this angle is 126 degrees. And the other angle that is a vertical angle with that is 126 degrees. That just leaves these two. Well, remember that these form a linear pair. So this other angle on the right side of N is the same as doing 180 minus 126, which would give me 54 again. So these are both 54 degree angles. Okay, now that's all the angles I could possibly have there. So let's identify the blanks that they're asking about. Okay, the first is angle MJK. Let's trace that. MJK, that is one of the corner angles of a rectangle. It is a right angle, so it is 90 degrees. MJL is this angle. That means it's the 63 degrees. Okay. JLK is also 63 degrees. KML is 27 degrees. And MNL is 126 degrees. Again, I'm just finding them in this picture over here. All right, and that's properties of rectangles. Now, we are going to continue to do some problems using properties of rectangles. Now, what I have here in this rectangle, I'm really focusing on this triangle because these are both angles of a triangle. And the easiest way to go about that is to think of this as a right triangle, which is why I added this property in for us to understand. In a right triangle, the acute angles are complementary, meaning that in this right triangle, these two angles at X and Z, neither one of them is the right angle, so those are the acute angles. They must add up to equal 90 degrees. They're complementary. So that's how I set up my equation. And the property I'm using is that in a right triangle, acute angles are complementary, meaning they add up to 90 degrees. In a right triangle, acute angles are complementary. They add up to 90. All right, so let's write that equation then. We can say that one angle measure, x plus 20, plus the other angle measure of the acute angle, 5x minus 8, equals 90. Not 180, equals 90. Now, I could do x plus 20 plus 5x minus 8 plus 90 equals 180, but it's a little bit easier to use this fact. So I'm going to combine like terms. X plus 5x is 6x. 20 minus 8 is 12. And then I'm just going to solve the equation. So I'll speed this part up. So when I finally divide by 6 on both sides there, I get x is 13. That's not the final answer. They want the measure of angle XZW. XZW is this angle measure here. All right? That angle measure is congruent to this angle measure because they're alternate interior angles and these sides are parallel. So all I have to do is plug back into that expression, 5x minus 8. So I'm going to do 5 times 13 minus 8. And when I do that, 5 times 13 is 65. 65 minus 8 is 57 degrees. Okay, one more example. So if RT is 5x minus 14, and they didn't write it in here, they put it in kind of sentence form, and US is 2x plus 10, find VT. Well, look at what we're using. RT is a diagonal, US is the other diagonal, and I'm going to find part of the diagonal VT. I'm using the main property that diagonals are congruent. And so I set these two expressions equal to each other first to find x. So 5x minus 14, that diagonal length, has to equal the other diagonal length of 2x plus 10. Again, we'll speed up so we can solve the equation. And we get that x is 8. That's not our final answer. They want to know the length of VT. VT is half of our full diagonal. So I'm going to take that RT length and divide it by 2. So I'm going to do 5 times 8 minus 14 and just divide all that by 2. Okay, 5 times 8 is 40. 40 minus 14 gives me 26. And I divide 26 by 2, and I get that VT equals 13. And you would understand both diagonals then would be a length of 26. Okay, so those are our properties of parallelograms and rectangles that we're going to use. It's very important for us to understand and remember these. You're going to refer back to these properties quite a bit. So make sure you have them copied down and you fully understand what those mean, and we're going to use those in solving problems like we did in the examples.